Hello students, welcome to Automotive Component Design. We are in Module 2. In Module 2, we are going to see the design of shaft. We are going to see about design of shaft. In the previous class, I gave introduction to this topic and we also solved one problem. In three ways, we can find the diameter of the shaft. One is based on the strength. Second one is based on the ASME code. Third one is based on the torsional rigidity. In the previous class, we have solved one problem based on the bending strength. Okay. Now we are going to solve another one problem. Let me read the question first. This question is in Design of Machine Elements book by V.B. Bandari. Author name is V.B. Bandari. This is the exercise problem. Page number 391. You can see this problem. Page number 391. Problem number 9.14. This exercise problem from Design of Machine Elements by V.B. Bandari. V.B. Bandari. Okay. So let me read the question first. A transmission shaft supporting two pulleys A and B and mounted between two bearings C and C2 is shown in figure. So this is the diagram given along with the question. This diagram, this one diagram, okay? This diagram and this and this given in the question along with the question. So here in this diagram there is a shaft. So this is a shaft, okay? This shaft is supported on the bearings C1 and C2. This particular shaft is supported on the bearing C1 and C2, okay? So it is getting power from the pulleys A and B, okay? It is getting power from pulleys A and B. A and B are pulleys and this is pulley diameter. Pulley B is 300 mm dia, having 300 mm dia, and pulley A is having 200 mm dia, okay? 200 mm dia, pulley A, inside pulley, okay? This is pulley B. Actually here we are seeing the side view of the shaft. So this is the front view and this is the side view, okay? So pulley A diameter is 200 mm and pulley B diameter is 300 mm. This is what they are given in the question. And in pulley A they are given a belt, okay? So this belt is vertically transmitting the power. In pulley A they are given a belt and this belt is vertically transmitting the power. Tension on the tight side of the belt is 2000 Newton. Tension on the slack side is 500 Newton, okay? On pulley A they are given a belt and this belt is in vertical direction, transmitting power in vertical direction, and on the tight side the force is 2000 Newton and on the slack side force is 500 Newton, okay? This is they are given in the question. Also pulley B, okay? Pulley B is also rotated by the belt, okay? Pulley B also transferring the power using a belt and this belt is somewhat inclined. See, this belt is somewhat inclined. They are given inclined line, no, that is belt. This belt is somewhat inclined and inclined by 30 degree to the vertical, okay? Inclined by 30 degree to the vertical, and this belt on the tighter side force is 1500 Newton and on the slack side force is 500 Newton, okay? So these are the things given in the question, okay? This diagram, this whole diagram from here to here they are given in the question, right? So draw the figure neatly with the help of scale and pencil. Draw the figure neatly with the help of scale and pencil. Give separate sheet for drawing the diagrams, okay? On the top draw the diagram given in the question. On the top draw the diagram given in the question. In the bottom we have to draw shear force and bending moment diagram, okay? Particularly load diagram and bending moment diagram we have to draw in the bottom. So give one separate sheet for drawing the diagrams, okay? So on the top draw the diagram given in the question, okay? Let me read the question again. So up to this we have read the question. Now power is transmitted from the pulley A to pulley B. So we have seen no two pulleys are there, pulley A and pulley B. Input is pulley A, output is pulley B. The shaft is made of plain carbon steel 45C8 and ultimate stress is 600 Newton per mm square and yield tensile stress is 380 Newton per mm square. the bullies are key to the shaft. Determine the shaft diameter using the ASME code. Okay, in the previous problem, we used normal method, normal strength method, bending strength method we have used in the previous problem. But now they told us to use ASME code, ASME code to solve this problem. Okay, and some constants. These are a fluctuating constant. KB equal to 1.5, KT equal to 1. Fluctuating factors. Okay. So also determine the, and I explained about these factors KB and KT in the previous video. If you don't know means please watch the first video and then come to this problem. Okay. Also determine the shaft diameter on the basis of torsional rigidity. So they told us to find the shaft diameter using ASME code. Also second time also we have to find the shaft diameter using torsional rigidity method. Two methods we are going to use in this problem. Okay. If the permissible angle of twist between the two pulleys is 0.5 degree, so angle of twist on the pulley is 0.5 degree, and the modulus of rigidity G, that is G value is 79,300 Newton per mm square. Okay. So two methods we have to use. First one is ASME code and second one is modulus of rigidity method. So using these, torsional rigidity method. First one is ASME code method, second one is torsional rigidity method. Using both of these methods, we are going to find out the diameter. Now let us extract the given data and write it down. First, what are the data they are given? They are given ultimate stress. Okay, ultimate tensile stress is 600 Newton per mm square. Write it down. Then yield tensile stress 380 Newton per mm square. Okay, write it down. Then KB, KT, that fluctuating factors. Okay, that is KB 1.5, KT is 1. Okay, so write those things here. Then angle of twist they are given 0.5 degree. Then rigidity modulus they are given 79,300. Write those things. Now what we have to find? We have to find out the diameter of the shaft. We have to find out the diameter of the shaft using two methods. First one ASME code, then torsional rigidity. Write those things. Okay. What are the formulas we are going to use? We are going to use only two formulas. Only two formulas will be used in this problem. And both of these formulas will be available in the data book. Okay. So you don't worry about the formulas. Only two formulas. First formula for ASME code. Okay. For ASME code formula is tau max equal to 16 divided by pi d cube. See, we are going to find this d. This is a question. Okay. We have to find this d. Tau max equal to 16 divided by pi d cube root of kb mb the whole square plus kt mt the whole square. Okay. This is for ASME code. So we have to substitute all the known answer inside KB value, MB value, KT value, MT value, tau max value. If you substitute all these 5 values means you will get D value. Okay. Next formula is for torsional rigidity method. For torsional rigidity method formula is D power 4 equal to 584 into MT into L divided by G into theta. 584 into MT into L divided by G into theta. Okay. Now we will move to solution. So they are given SYT value and SU2 value. Okay. Maximum yield tensile stress and ultimate tensile stress they are given. Okay. According to ASME code, okay, there is a rule for permissible shear stress. For permissible shear stress, it will be equal to 0.3 into SYT. Otherwise, permissible shear stress equal to 0.18 into SUT, ultimate. Okay. In the question, they are given yield tensile stress. Also, they are given ultimate tensile stress. So we will use both the method and we will find the tau max value. Okay. Tau max equal to 0.30 into SYT. SYT value is 600. Substitute the value. I am getting the answer as 180. Similarly, tau max equal to 0.18 into SUT. 0.18 into SUT value is 380. Substitute the value. We will get the answer as 68.4. Okay. We got two tau max value. And this is also available in the data book. Okay. This tau max equal to 0.3 into SYT, tau max equal to 0.18 into SUT. These two formulas also available in the data book. Okay, they are given SYT value and SUT value. Okay, Suppose if they given only SYT value means we don't want to bother about these things. But they given both the value, so we have to find out tau max value 2 times. So using SYT we got answer as 180. Using SUT we got answer as 68.4. Whichever the value is lower, we have to take that value. Okay, while comparing 180 and 68.4, 68.4 is lower, that is SUT. SUT, using SUT we got the answer, no, that is lowest value. So we have to use that as permissible shear stress. Okay, for a better safe design, the value should be permissible shear stress should be lowest value. So the lowest value is 68.4. So I will take tau max as 68.4 Newton per mm square. Okay, for a safe design, tau max should be lowest value and the lowest value is 68.4. Okay, I got the value. Now next, now I need MT value and MB value. See, in this formula they have used MB value and MT value. In this formula also they have used MT value. Okay, other than that we know length value they are given in the question. In the diagram you can see length value, torsional rigidity G value they are given, theta also they are given 0.5 degree. But still we need to find out MT value and MB value. If we find out MT value and MB value means we can finish this problem. Okay, first let me find MT value. MT means torsional moment. MT means torsional moment. MB means bending moment. Okay, MT means torsional moment. MB means bending moment. First let me find MT value. We can easily find the MT value. Okay, we can easily find the MT value because they have given two pulleys, no? They have given two pulleys, pulley A and pulley B they have given. They have given two pulleys, pulley A and pulley B they have given, and they have given the load on the pulley, particularly in both the pulleys are rotated by the belt. Okay, both the pulleys A and B are rotated by belt, and in the question they have given the load acting on the belt. Load acting on the belt. See, for pulley A, 2000 Newton and 500 Newton are the load acting on it. So torsional moment equal to load into distance. Okay, torsional moment equal to load into distance. Suppose if we take pulley A means, about the center point. Okay, about the center point, take pulley A. Okay, how many loads are there on pulley A? On pulley A, two loads. On this side 2000 Newton, on this side 500 Newton. So let me take that. On 2000 Newton load into distance. So 2000 Newton load is acting on this point, and distance between this point and this center is 100 mm because diameter is 200 mm. So for center portion distance will be, radius will be 100 mm. Okay, so this load 2000 into 100, that's what I have written here. Okay, 2000 into 100, that is rotating in, now this is in anti-clockwise direction. This is in anti-clockwise in direction. About the center, this is in anti-clockwise direction, so I have to put plus in front. Okay, so plus 2000 into 100. Similarly, one more load is there, that is 500 Newton, and this 500 Newton load is acting clockwise direction. 500 Newton load is acting clockwise direction, and between the center to this 500 Newton load is that also radius 100 mm. So put the value here. Okay, but since it is rotating clockwise, you have to put minus. Okay, so we are getting the answer as 1,50,000 Newton mm. 1,50,000 Newton mm. If you take shaft B, there also you will get the same answer only. Okay, if you take shaft B, there also you will get the same answer only. But in the examination, take any one shaft. Take shaft A or shaft B. But you should know both the load value. Suppose they given the belt means you should know load acting on this side and load acting on this side. Okay. So both the values you should know. If you know both the value means you can directly find the MT value. You can find it for pulley A or you can find it for pulley B. Suppose if you are finding out the value for pulley B means there also you will get the same value. See, from center to this load, distance is R of the pulley B. Radius of the pulley B will be 150 mm because diameter is 300 mm. So radius will be 150 mm. From this point to this load, radius is 150 mm. So same thing, 1500 into 150 minus 500. This side 500, no, 500 into 150. Okay, if you put means here also you'll get the same value, 1,50,000 value will get. Yeah, you don't want to calculate MT for both the shaft. Any one shaft you take, you will get the same answer only, because both bully A and bully B are attached in single shaft only. Okay, so throughout the shaft, MT value is same. Wherever you take, MT value will be same throughout the shaft. Okay, right. So I got torsional moment value. Torsional moment value is 1,50,000. Now I can substitute this value in rigidity basis method. In rigidity basis method, formula is d power 4 equal to 584 into mt into L divided by g theta. 584 instead of mt put 1,50,000. L value from this point to this point, overall length. This is the length of the shaft. 100 plus 200 plus 150. This is the length of the shaft. So total length is 300, 450. Okay, 450 is the total length. Sorry. The total length is 400, but you have to take length between the pulleys. Okay, we have to take length between the pulleys only. I'm sorry, we should not take the total length. Total length is 450 mm. We have to take the length between the pulleys. Length between two pulleys. Length between two pulleys are 200. Okay, so substitute the value 200 here. So 584 into MT value 1,50,000 into 200 divided by G value. In the question they are given, G value is 79,300 into theta value 0.5 degree. You just substitute the degree value as it is. In certain cases, we will convert the degree into radian, but here we don't want to convert the degree into radian because already they have done those conversion. So we have substituted all the values and now we got the answer as 441866. Okay, 4,41,866. So d power 4 equal to 4,41,866. 441866. Now you have to take you have to take root. Okay, if you take root means root of 4. If you take root of 4 means you will get the answer as 25.78 mm. Okay, so one answer we got based on the rigidity basis, rigidity strength. Okay, rigidity modulus, based on rigidity modulus, we got the answer as 25.78 mm. Okay, so still we have one more method, that is ASME method. So to use ASME method, I am telling you again. Now we got tau max value, KB value, KT value they given in the question, MT value, just now we got MT value. Still we have to find MB value, that is bending moment value. This is the crucial thing in this problem, finding out the MB value. Okay, MB means bending moment. You might have studied in strength of materials about shear force diagram and bending moment diagram. If you know some basics from those topics, then only you can solve the further problem, because we have to find out the bending moment value using bending moment diagram. Okay, so you should know certain basics from the shear force diagram, bending moment diagram that you have studied in strength of materials. Okay, before that on shaft A they are given the force in the vertical direction, that is downward direction. In downward direction they are given the force, so no problem about that. But in shaft B they are given the force in the inclined manner. They are given the force value in the inclined manner, that is also 30 degree to the vertical. Okay, so this force is inclined force. Now we can't solve the problem as it is. We have to convert this inclined force value to horizontal and vertical. We have to convert this inclined force value to vertical and to horizontal. Similarly, so we are going to convert this 500 Newton 30 degree angle. Now we have to convert it into horizontal force and vertical force. Similarly here 1500 Newton. We have to convert this 1500 force into horizontal and vertical. Okay. So let us see how we can convert those force into horizontal and vertical. So I am drawing the diagram again. I am drawing the pulley diagram again. Pulley B pulley B has been drawn again. So 500 Newton, 1500 Newton and 30-degree angle. Now we have to split this force into vertical and horizontal. Similarly, split this force into vertical and horizontal. This is very simple. If I want to split this force into vertical force means I have to multiply this value with the cos 30. Okay. If I want to get the horizontal force means I should multiply this value with the sin 30. If I multiply 500 with the sin 30 means I will get this horizontal value. If I multiply 500 with the cos 30 means I will get vertical value. Similarly here also, if I multiply 1500 with the cos 30 means I will get the vertical value. Similarly, if I multiply 1500 with the sin 30 means I will get the horizontal value. Okay. So I have done it here. Okay. I am splitting the 500 Newton force into vertical and horizontal component. To make it into horizontal component, multiply it with the sin 30. To make it into vertical component, multiply with the cos 30. Okay, 250 Newton, 433 Newton. Similarly here also, 1500 Newton, that also, this force also, split it into horizontal and vertical. Okay, to split it into horizontal force, the value is 750. Vertical force, 1299. Okay, so now we have split the inclined force into horizontal and vertical. Okay, now let us draw the force diagram for vertical plane. Let us draw the force diagram for vertical plane. Okay, we are going to draw force diagram for vertical plane. So first you draw the line diagram for the shaft. Okay, this length, just draw it here. Okay, we are going to draw the vertical loads. All the vertical loads we are going to draw now. Okay, so on C1 and C2, on C1 and C2 there will be a reaction force. On C1 and C2 there will be a reaction force. So first to draw the reaction force on C1. Okay, vertical reaction force 1. On C2, vertical reaction force 2. Okay, 2 reaction force will be there on C1 and C2. Okay, I have drawn that. Next, on bully A, see, this is bully A. On bully A there is a downward load, no? So there is a downward load, 2000 Newton and 500 Newton. Both loads were down load. So add both the loads, 2000 plus 500, 2500. So below pulley A, draw a vertical line and mark it out. Downward direction, because both the loads are acting in downward direction. 2000 plus 500, 2500 Newton. Right. Next we will go to bully B. On bully B, we converted this inclined force into vertical and horizontal. Similarly, we converted this 1500 vertical force into vertical and horizontal. Okay. So 1500 vertical component for 1500 is 1299. Okay, vertical component for 1500 is 1299. Vertical component for 500 Newton is 433. So add this 1299 and 433. Add 1299 and 433. We will get the answer as 1732. And see, they are acting in the upward direction. Both the loads, vertical for 500 Newton and vertical for 1500, both are acting in upward direction. Okay, I am telling you again, vertical for 500 Newton is 433 Newton. Vertical for 500 Newton is 433. Vertical for 1500 is 1299. Okay, so add both the value and we got 1732. Okay, so I have drawn force diagram for vertical plane. So in this vertical plane, two reaction forces were there, RV1, RV2, and one downward force 2500 and one upward force 1732. Okay, so here we have two unknown values, reaction force RV1 and reaction force RV2. Both are unknown values. We have to find RV1 and RV2. Then only after finding out the RV1, RV2 only we can draw this bending moment diagram. Okay, we have to draw this bending moment diagram. But without knowing this RV1 and RV2, we can't draw this bending moment diagram. So let us find RV1 and RV2. So what are the downward forces? RV1, RV2 and 1732 are downward forces. See, RV1, RV2 and 1732. All the three were downward forces. upward forces, RV1, RV2 and 1732. All the three were upward forces. So write it down here. All the three upward forces. And 2500 is downward force. So write it this side. Okay. Now you take moment about any one point. Take moment about C1 or take moment about C2. Because at both the extreme ends on the supports, particularly on the supports, bending moment value will be 0. Okay. You take any one point. That is your wish. I am taking point C1. I am taking point C1. If I take point C1 means on C1 moment value is 0. Okay. So now we have to tell the load value, no? So first one, downward load 2500, and that is acting in clockwise direction. 2500, the distance between 2500 and C1 distance is 100. Okay. So 2500 into 100. Since it is acting clockwise direction, we have to put minus 2500 into 100. Next is 1732. It is acting in counterclockwise direction. Okay. And the distance between the load and the C1 is 300 mm. 100 plus 200, 300 mm. Similarly, last load, that is also acting upward, that is counterclockwise. So that also we have to put plus RV2 into distance between C2 and C1. Distance is 450. Okay. That's what I have written here. So we are finding the bending moment at C1. If you do this calculation means you will get the answer for RV2. I am getting the answer as minus 500 Newton. Minus 500 Newton, 599 Newton. Okay, minus 599 Newton. What I am going to do means I am going to change the direction. Initially, I put reaction force in the upward direction. But I got the answer in minus. So I have to change the direction. The reaction force V2 will be acting downward. Now substitute this 599 here. Okay, 599 here. If you substitute 599 here means you will get the answer as 1367. But this is acting upward only. Okay, because we got the answer in plus. Okay. Since I got the answer in minus, I have changed the reaction force direction. Initially it was upward, now I have changed it to downward. Okay. So that is here, initially it was in upward direction. Now hereafter I have to put this in the downward direction. Like I have to erase it. And change the direction to downward. Hereafter it will be in the downward direction. Since I got the answer, negative answer, so I am changing the direction. Okay. So I hope till now you understood. So I have changed the direction. Okay. Okay, right. Now I have to find out the bending moment value at point A and point B. Okay, I have to find out bending moment value at point A and at point B. So first let me take point A. Okay. On point A I am going to find out bending moment value. Okay. You can come in any direction. I am coming from this direction. Okay. At point A I am going to find out bending moment value. So MA equal to first value 1732. 1732 is acting counterclockwise. So plus 1732 into this distance. Distance is 200. Yeah. 1732 into 200. See, if I am going to find out bending moment at point A means I have to consider load at this side or load at this side. Any one side I can take. Okay. Any one side. One thing I have to come from this side or I have to come from this side. Okay. But I am taking these two values. I am going to come from this side. Okay. I am going to come from this side. So first value 1732. 1732 is acting in the counterclockwise direction about point A. So this is point A, no? So about this point 1732 is acting counterclockwise. Between 1732 and point A distance is 200 mm. 1732 into 200. Next one RV2. RV2 is acting clockwise. So minus RV2 into distance between RV2 and the A is 350 mm. RV2 into A. Since it is acting clockwise, I have to put minus. See, I got the answer. RV2 into 350, 1732 into 200. Since RV2 is acting clockwise, I have to put minus. So the final answer is 136750. 136750. Similarly, I have to find out bending moment at point B. About bending moment at point B. Bending moment at point B. Here, we have to take either this side or this side. Okay, va? Any one side I have to take. But I am taking this side. Since it is having only one load now, so I am taking this side. RV2 into distance. RV2 value 499, I think so. That into distance. Distance is 150. Sorry, 599. RV2 is 599. 599 into 150. Since it is acting clockwise, I have to put minus. Okay. So the final answer is minus 89850. So for vertical plane, moment acting at A is 136750. For vertical plane, moment acting at B is minus 89850. Now we have to go for horizontal plane. Okay, now we have to go for horizontal plane. Same shaft, draw the line diagram again. Okay, C1 to C2, mark all the points. C1, A, B, mark all the points. Okay, so first on either bearings C1 and C2 there will be a reaction force. On C1 RH1, C2 RH2. Okay, va? So I have noted both the reaction force. Now on bully A, only vertical force is there. There is no horizontal force. So on bully A, there is no need to draw any load. Okay, because if there is horizontal load, I have to draw it. Okay, let me go to pulley B. But for bully B, 500 Newton, it is having a horizontal component. 500 into sin 30, that is 250 Newton. Okay, for this horizontal component is 250 Newton. Similarly, for this 1500 Newton, it is also having a horizontal component. 1500 into sin 30, the value is 1299. Okay, so it is having two horizontal components. First horizontal component is 499. Okay, sorry. First horizontal component is 250. First horizontal component for 500 horizontal component is 250. For 1500 horizontal component is 1299. Let me see. Sorry, for horizontal component for 1500 is 750. Okay. Horizontal component for 500 is 250. Horizontal component for 500 is 250. Horizontal component for 1500 is 750. 250 and 750. Okay. So 250 and here 750. Two horizontal components were there. Okay. So both are acting in same direction. This is also acting in this direction. 750. This is also acting in this direction. Okay. Both are acting in same direction. So add 750 and 250. You will get the answer as 1000. Okay. So on B, horizontal component is 1000. On B, horizontal component is 1000. Okay. On C1 and C2, reaction force is there. Now I have to find reaction force on C1 and C2. Okay, as usual, add the vertical components, vertically upward components, RH1 and RH2, vertically upward. Vertically downward component 1000. Okay, write it. Next, take moment about C1 or C2. Take moment about C1 or C2 because on both the bearings, moment value will be 0. C1 and C2. Any one bearing you take. I am taking C1. Okay. So MC1 equal to 0. How many forces are there after this? Two forces. So 1000 into this distance B2C1. B2C1 distance is 300. 1000 into 300 and acting in clockwise direction. Okay. So minus 1000 into 300. Next RH2. RH2 is acting counterclockwise direction. So RH2 into what is the length between C1 and C2? The total length between C1 and C2 is, I think, 450. Okay. That's what I have written here. Minus 1000 into 300, 450 into RH2. Now find the value of RH2. If you equate means you will get RH2 as triple six. Substitute this triple six in this formula. You will get RH1 value. RH1 value is 333. Okay. RH2 is 666. RH1 is 333. Now we have to draw the bending moment diagram. Now we have to draw the bending moment diagram. Okay. Now we have to draw the bending moment diagram. So for that I need at two extreme ends bending moment value is 0. Only one more point is there, that is point B. On point B, what is the bending moment value? That I have to find out. So on point B, if you come from this side, for point B, if you come from this side means RH2 into this distance. RH2, this distance is 150 mm. RH2 value is 666. 666 into 150. 666 into 150, the value is 99999. Okay. So the bending moment value is 99999. So mark it above B. Mark it above B. See, in this diagram I forgot to tell you one thing. Okay. For horizontal plane also we got bending moment value for A, bending moment value for B. Bending moment value for A is 136750. Bending moment value for B is minus 89850. Since the value is minus, I am marking the point below this line. I am marking the point below this line. Okay, below B. Similarly here also, here the answer is in plus. So mark the point above this line, exactly above A. That's all. Similarly here also, now we got answer as 99999. 99999. Mark this point above B. Anywhere you can mark. Okay, anywhere you can mark. I marked here. And connect C2 and C1. Now this line is crossing A. This line is crossing above A, no? So I have to find out bending moment at this point. But I don't know the value. But I need the value. I need the value, but I don't know the value. Bending moment at A, I don't know the value. How I can find? Mark that point. Okay. Consider that as X. Consider that as X. See, here C1AX. C1AX. It's a triangle. Okay. Similarly, C1BY. This is also triangle. C1AX, that is also triangle. C1BY, that is also triangle. The interesting thing is C1AX and C1BY are similar triangle. C1AX and C1BY are similar triangle. Similar triangle means their height breadth ratio will be same. Height breadth ratio means C1A divided by AX will be equal to C1B divided by BY. Okay. C1A means this length. What is this length? This length is 100. Okay. That's what I have written here. C1A is 100. Okay. Similarly, C1B length is 300. BY value is 99999. Now we got X value was 33333. That is bending moment at A equal to 33333. I am repeating again. This is the bending moment diagram for horizontal component. Here C1AX and C1BY are similar triangle. Similar triangle means their height versus breadth ratio will be same. For example, BY divided by C1B will be equal to XA divided by C1A. So based on that, we got X value as 33333. So now we got both the bending moment diagram. Bending moment diagram for bending horizontal component and bending moment diagram for vertical component. So in vertical component also at point A bending moment is there. In horizontal component also point A bending moment is there. Similarly for point B also, in vertical component also there is a bending moment, and in the horizontal component also there is a bending moment. Now we have to find out the resultant bending moment. Together vertical and horizontal, what will be the bending moment at point A and what will be the bending moment at point B. So at point A, resultant bending moment value will be horizontal component square plus vertical component square. That is, at point A, root of vertical component bending square 136750 square plus 33333 square. Okay, root of 136750 square plus 33333 square. Similarly, at point B, resultant bending moment value will be root of 89850 square plus 99999 square. So that's what I have written here. So if you find the root, means at point A value is 140753, at point B value is 134435. Whichever the highest value, you have to take that as bending moment. Okay, for A value is 140753, for B value is 134435. Comparing both, bending moment value at A is higher, so I am taking that as MB. Already I have MT value, so we know the formula. Tau max equal to, for ASME code method, tau max equal to 16 by pi d cube kb mb square plus kt mt square. Now substitute the value. Kb value 1.5, kt value 1. Okay, substitute those values. Kb into mb will be equal to 21129. Kt into mt equal to 150000. Okay, tau max value is 68.4. Substitute all the values. Now we got d cube as 19283. Take cubic root, you will get the answer as 26.8 mm. So based on rigidity method, we got 25.78. Based on ASME code method, we got 26.8 mm. So this is the diameter of the shaft using both the methods. So this is very simple. Only two formulas. This is for ASME code method. This formula is for rigidity method. Okay, only two formulas. But the thing is, you have to find out MB value, MT value. MT value easily we can find out. But for finding out MB value, we have to draw bending moment diagrams for vertical plane and horizontal plane. Because forces acting in vertical direction, also in horizontal direction. So we have to draw bending moment diagram for both cases. Suppose if the force is acting only in the vertical direction, means, so bending moment diagram for vertical direction is enough. Suppose if the force is acting on only in horizontal direction, means bending moment diagram for horizontal direction is enough. But here forces were acting in two directions, vertical and horizontal. One more thing, here inclined manner force is acting. I am splitting it into vertical component and horizontal component. Okay. So very simple, but you have to practice it, and you should have a basic knowledge about bending moment diagram, so that you can easily solve this problem. In the next class, we will solve one more problem. So this is the answer. Book answer will be somewhat different. For rigidity method, you will get the same answer, but for ASME method, in book you might get the answer as 25.3, I think so. There might be a small calculation mistakes. So we got 26.8 as the answer.